Welcome to my YouTube channel again. Today we are going to talk about scientific method. This is like a global approach to solving scientific problems. This is what scientists use. For you to remember these steps in order, it's good to learn this mnemonic right here on the bottom. It says Peter Rabbit hates eating dirty carrots. The P is for problem, the R is for research, the H is for hypothesis, the E is for experiment or experimentation, the D is for data, and the C is for conclusion. Here are the steps. Let's go talk about each one. Problem is always in the form of a question. You're asking a question. Why is my head hurting me? Research. You go and research why your head hurts. What could cause headaches? What do you think would cause headaches? That's your research, right? And once you do the research, you can now make that logical guess, that hypothesis. You can now make a prediction. That educated guess is based on the research. When you have made your hypothesis, when you have stated the hypothesis, now you need to test it. You can't just state it and move on and say, oh, done. You have to test it to see if your prediction is right. So you're going to test it. That's the experiment. Test the guess, I like to say. Data. Collect information during the experiment. That's all it means, collected information. Conclusion, I like to call this the wrap-up step, where you put a big fat bow on it and say, I got the results, or I got what I need, or I solved the problem, or whatever it is, okay? So based on the experiment, if the hypothesis was proven to be true or proven to be incorrect, you got to state it in the conclusion. Here's an example. On a television talk show, a guest claims that people who exercise vigorously, that means you're working out, doing jumping jacks, whatever you need to bring on the sweating, the palpitating of the heart, the fast beating of the heart, that's vigorous exercise. Okay, they need to do this for 15 minutes on a daily basis. And if they do this, they're able to solve math problems more quickly than those people who do not engage in rigorous exercise every day. Okay, on the bottom you see it says describe in red. Describe, that's what I want you to do. Describe a controlled experiment. Not just experiment, controlled experiment. That means you need two setups that could be conducted or performed that you can actually test, okay? Now, before you do anything like answer these bullets as part of the task that needs to be done, before you attempt to answer any of those bullets, the first thing you should do is make a T-chart like that. Okay, you see here that you need two setups, and you know that the control group, this group right here, will only be for comparison purposes. We'll only need it for later. Just compare, just to see what this looked like and what they did and what they were able to do with the math problems, and compare it to these subjects in this group. Okay? Now, control group versus the experimental group. As you can see, my first row says 100 subjects and 100 subjects. The subjects need to be the same amount. The number need to be even, Steven, equal. Then it usually asks for two. As you can see, I did three. 1, 2, 3. Usually it asks for two constants, or what we call control variables. Two things in the experiment that you are able to control. Like, for instance, the amount of math problems that should be given to the control group must be the same amount that must be given to the experimental group. The same type of math problems that must be given to the subjects here must be given to the subjects here. If you're given the subjects in the control group 20 minutes to solve these problems, you need to give the same amount of time to the experimental group, subjects in the experimental group. As you can see at the bottom here, that last row, you will see the control group says, I am not going to give them, I'm not going to let them do, I'm not going to let them engage. They will never engage in vigorous exercise. But the experimental group will do vigorous exercise. We'll just do jumping jacks, or run in place, do the running man, whatever they need to do to get their hearts pumping so that they can, circulate the blood to their brain so that they can have more oxygen in their brain so they can do the problems a lot faster than the subjects here. Okay, now we can tackle each bullet. It says, state the purpose of the experiment. I know what the purpose is. From here, see that right here? A guest did this. A guest claimed, right? So we want to make sure that claim that was made is true. So the purpose of the experiment is to test the claim. Why should the sample be large? Well, the bigger the sample, the more valid the experiment. So you want a large sample so you can have a more truthful experiment, more valid. Third bullet, describe how the experimental group and the control group should be treated differently. Well, go back to here, the T-chart, you'll see right here at the last row, the experimental group will engage in vigorous exercise while the control group does not. So here it is, right here. This group will do exercise, vigorous exercise. This group will not. Fourth bullet, state the specific data that should be collected. Data. Information that should be collected. Well, I think that the data should be collected should be the amount of problems that were solved in the given time. That would work. That's data. Data is always written in numbers. Okay? Use numbers to write data. State one way to determine if the results support the claim. Well, the claim made earlier said if people do vigorous exercise on a daily basis, they will solve math problems faster. So the experimental group, the subjects in the experimental group should be able to solve the problems faster. So count the amount of math problems that were completed in the given time, the number of math problems, the amount. Oh, by the way, let me go back up here for a minute. The vigorous exercise written in red right here, this will be your X. This will go on the graph, the X axis, while the data collected, that they want right here will be the Y, that will go on the Y axis, the information, the numbers. Okay, answers. To see if the claim is true or valid, to make the experiment more valid or truthful, the experimental group will do vigorous exercise while, and by the way, see it in blue, that's the independent variable, and the control group will not engage in vigorous exercise. The number or the amount of math problems done in the given time will be the data that goes on the Y. That's a dependent variable, the Y-axis. Subjects who did vigorous exercise, look at that, solve more math problems in the given time. So the subjects in the experimental group should be able to solve more problems in the given time than the subjects in the control group. Okay, 2 ways to make any experiment more valid. Repeat it, repeat it, repeat it. You just finish doing the experiment. You don't go, I'm finished. No, you have to do it again because you want to make sure that the results you get when you repeat it will match the result that you got before the first time you did it. Then you're going to do it again the third time, and the fourth, and the fifth, and the sixth, and the seventh, and the 8,000, whatever. You keep doing it again and again and again and again. You're supposed to get the same results. Okay? If you look at it, the results should be the same in all 20 tries, in all 1,000 tries. So if you do the experiment 50 times, the results must be the same. Okay? You can't say, well, it's a little bit different here. Nope, then your experiment is invalid. Okay? Also, the second way to make any experiment more valid, use more specimen, more subjects. If you have humans and you're using 500 in the experimental group and 500 in the control group, why not use 1,000 in each group? Why not use 2,000? The bigger the number, the more valid the experiment. Okay, I hope this helped. See you next time when I'm going to put up my next video, okay? Take care.